Dear students, myself Akshata, physics lecturer. Let us discuss the chapter Dual Nature of Radiation and Matter. Radiation means light. Dual nature of radiation means light has two types of nature. Light sometimes behaves like a particle and sometimes behaves like a wave. Okay, that is the meaning of dual nature of radiation. Next, proofs for wave nature of light. Certain optical phenomena such as interference, diffraction and polarization of light establishes wave nature of light. The second proof is Maxwell's equations on electromagnetism, and the third one is Hertz's experiment on electromagnetic waves. These confirms the wave nature of light. Okay. Next, proof for particle nature of light. Photoelectric effect and Compton effect establishes light has particle nature. Okay. Let us discuss the introduction part of this chapter. In 1819, William Crookes suggested that cathode rays are stream of negatively charged particles. Okay. Later, in 1897, J.J. Thomson experimentally confirmed this fact. Means he experimentally confirmed that cathode rays means those are stream of negatively charged particles, and he named these particles as electrons. Okay, so electrons are negatively charged particles. Okay, and also he experimentally found the speed of the electron and specific charge of the electron. Specific charge of the electron is charge to mass ratio of the electron. It is found to be 1.76 into 10 raised to 11 coulomb per kg. As you know, coulomb is SI unit of electric charge and kg is SI unit of mass. And also he suggested that electrons are fundamental and universal constituents of matter. Okay, so remember this point. And also the electron was discovered by J.J. Thomson. Okay, next in 1913 R.A. Millikan conducted oil drop experiment to measure charge on electron. He found that charge on an oil droplet was always integral multiple of elementary charge E. As you know, the basic unit of charge or elementary charge is denoted by small e and its value is 1.602 into 10 raised to minus 19 coulomb. Okay, this experiment established two factors. First one is electric charge is quantized, means charge on any body can be written as Q equal to plus or minus Ne, where E is elementary charge and N is integer. It takes value 1, 2, 3 up to so on. Here, on substituting the values of N, then we will get Q equal to plus or minus 1E, plus or minus 2E, plus or minus 3E up to so on. So, charge on any body can take these values only. That is the meaning of quantization of the electric charge. Okay, and the second factor is charge on electron is equal to minus 1.602 into 10 raised to minus 19 coulomb. Next topic is work function of the metal. It is denoted by pi naught. Okay, so we know that free electrons means those electrons are loosely bound to the nucleus and are free to move inside the metal surface. Okay, these free electrons are held inside the metal by attractive force of the ions. Okay, So an electron can come out from this metal surface only if it has got sufficient energy to overcome this attractive force. Okay, that supplied energy is called as work function of the metal. Okay, hence here the work function of the metal can be defined as it is minimum energy required for an electron to escape from the metal surface. Okay, so its value is constant for a given metal and it is measured in electron volt. As you know, in mechanics, joule is used to measure energy. But in atomic and nuclear physics, a new unit is established, that is electron volt is used to measure energy. Okay, so hence there will be some relation between electron volt and joule because both are units of energy. Okay, hence here the 1 electron volt can be written as 1 electron, or E means what here? The value of E equal to 1.602 into 10 raised to minus 19 coulomb. Okay, here volt means it is the SI unit of potential difference. So hence here this is equal to, so 1 electron volt is equal to, it is product of 1.602 into 10 raised to minus 19 coulomb and 1 volt. That will give rise to 1.602 into 10 raised to minus 19 joule. Coulomb volt is called as joule. Okay, here the electron volt can also be defined. So it is defined as 1 electron volt is energy gained by the electron. Okay, it is energy gained by the electron when it has been accelerated by potential difference of 1 volt. Potential difference of 1 volt. Okay. Next topic is electron emission. Electron emission means emission of electrons from metal surface. Okay, such process is called as electron emission. Okay, the energy required for electron to escape from the metal surface can be supplied from some external sources. Depending upon the sources of external energy, the electron emission is classified into 4 types. First one is thermionic emission, second one is field emission, third one is photoelectric emission, and the last one is secondary emission. Let us discuss one by one. First one is thermionic emission. Okay, thermionic means heat. So it is the process of emission of electron from heated metal surface. Okay, so in this process heat is supplied to undergo the emission of the electrons. Here the electrons emitted in this process are called as thermions, and here a metal is heated to sufficiently high temperature is about 2500 degree Celsius. Okay, which enables the electrons to escape from the metal surface. Here the number of electrons emitted per second per unit area depends on temperature of the metal. Means here temperature is more, then the more number of electrons are emitted. Okay, such type of emission is employed in electronic vacuum tubes and cathode ray tubes. The second process is field emission. It is the process of emission of electron by the application of strong electric field to the metal surface. Okay, here the stronger the electric field, greater will be number of electrons emitted. Okay, so this process is also called as cold cathode emission, and this type of emission is used in X-ray tubes. Third type of process is photoelectric emission. Photoelectric, photo means light. Okay, in this process light is used, or light is incident on the metal surface, then the electron will be absorb the enough energy and will escape from the metal surface. Hence, it is the process of electron emission from metal surface when radiation of suitable frequency is incident on it. Okay, right. Here the energy of incident radiation is transferred to the electrons in the metal surface, and those electrons are liberated from the metal. Okay, such type of emission is used in photocell. Okay, and the last process is secondary emission. Secondary means here the fast moving electrons are used to achieve the electron emission process, hence the name secondary emission. Okay, it is the process of emission of electrons from metal surface when large number of fast moving electrons strikes it. Okay, so here such type of emission is used in photomultiplier tube. Okay, in next class we will study photoelectric effect.